Thank you very much. Let's get started. So let me just move these webinar windows out of the way.
We don't see
Okay.
it, by the way.
Oh, you don't
We
see
don't
it?
see that.
Okay. Yeah, but they're across the slides, so I couldn't see the slides properly. Okay. So we're going to talk about database fault today, and the issue is that you maybe don't have it, you maybe can't afford it, maybe you're using standard edition of Oracle, so you can't actually use it anyway. So I just want to look at to start with a high level of what is database fault and what does it do, and then talk about what we could do instead if we can't afford it or we don't have it. So just a little bit about me first. I've been doing Oracle security, only Oracle security, since around 2001, and I started my own company in 2003, at the beginning of 2003. So I do security audits. I help people design things like database vault, virtual private database, label security, audit trails. I do forensics, and as we've just seen, I've just written a book on this subject. I'm an Oracle Ace, a member of the Oak Table, and I think that's enough about me. So we're going to talk about two elements. What is database fault? It's a fairly high level. What does it do? What are the main components of it? Does it actually work? Does it actually protect your database? And then in part two, we're going to talk about what can we do to simulate some of the features of database fault if we don't have it. In other words, we can't install it or we can't afford it. What's possible to do for free. So I've got a few little demos to do as well a little bit later on, primarily on part two, just showing what we can do to simulate features of database fault. So we'll get to those a little bit later. So it's not just talking and slides. There is some demos as well. So what is database fault? It's a declarative, I can never say that word, declarative framework. In other words, you declare the rules, the policies, the settings. You can do it with PLSQL, but you can also do it through Cloud Control. And you design your settings and rules for database fault using a declarative framework. So you're defining generally anonymous blocks and defining policies, defining factors and rules and so on. We'll talk about what those bits are in a minute. These are normally grouped into realms to protect things like tables or views or procedures. There's literally unlimited context-based security in this. So basically anything you can add that can control or tell you something about the account that's logged in, so the time of the day, the screen you're currently in, the name of the database, obviously the username, which roles are enabled. Any of these sort of elements can be used to decide whether a particular security rule is enabled or disabled. And this is what gives it its context-based security. So you decide what the context is, and then you use that within the rules of database vault. Its default purpose is to protect against system any privileges. So the system privileges with the word any in them. So select any table, insert any table, delete any table, any of these type of privileges. By default, these are sweeping privileges. So if you've got insert any table or select any table, you might need to only look at the tables in one schema, maybe the Orablog schema in my sample database. Well, that means you can actually look in the tables of any other schema. So these privileges are dangerous. And by default, people grant these privileges. So this was one of the premises. The other element is the separation of duties. So when you install database vault, it gives you three sort of high-level roles by default. So it gives you security administrator, the user account administrator, so the ability to create, drop, alter user accounts, and the vault owner. So when you install database vault, users like sys and system and DBA are restricted in value, so they can no longer change passwords, for instance. They can no longer create users. So this is done as default hardening when it's installed. In 12c, because it's built in, it's much easier to enable because it's shipped by default. The label security and the database vault are already there. You enable them through package procedure calls. In 11G, it was a little bit harder because you had to recompile or relink the database code to enable database vault. So it wasn't massively harder, but it was slightly harder. So it's built into the database kernel, which means it's harder to bypass it or get around it or to trick the security. So it's a good solution. It's a good tool. I like database vault because it's actually there built into the database with the data, so it makes it harder for anyone to beat the security. What's new in 12? Pre-installed, as I've just mentioned, so you don't have to install it separately anymore. It works with multi-tenant, so if you're using multi-tenant database, it already works. There are some issues around this, so you must install it in the root container first before a pluggable container. Also means that by default you get it in every container in this sort of scenario. It can be managed with common accounts, delegated or local accounts, so there's flexibility. New in 12c is this thing called mandatory realms. So a mandatory realm basically means that by default, we just talked about the system any privileges. So access to a particular table, for instance, by default, database vault blocks the system any, so it blocks select any table. So if a user had a direct grant, a direct select privilege on, say, a credit card table, he's not blocked by a normal realm because that's decorative security that you've decided you need. Database vault sort of ignores that and says, okay, we know you need that security, therefore we're only going to protect sweeping security. In 12c, there is now this thing called mandatory realms, whereby you can create a realm that actually protects against the object owner, the owner of the table, or the procedure, or whatever, and also protects against the direct grants. So it works to a more detailed level. This was possible in 11, but it was harder to do. Also in 12, one of the major new features is privilege analysis. So the ability to enable a privilege analysis within your database and do some work and then see which privileges were used, or more importantly, which privileges weren't used. You can then use that information to decide how you're going to establish least privilege in your database. When you install Database Vault, you also get some basic hardening. So some of the parameters that are in the CIS benchmark or the DoD STIG or Oracle's list, which disappeared a couple of years ago, Oracle Security List, these are enabled by default. So things like auditing sysdba or things like selecting a dictionary are turned on by default. So just simply the process of enabling Database Vault actually increases the basic hardening of your database as well. There are some shipped policies that have already been designed and built for things like eBusiness Suite, PeopleSoft, SAP, and things like new features like Unified Audit also works with Database Vault. The interesting thing with Unified Audit is that if you look at the core audit settings in a 12c database that are given to you by default, so the things that were generally in the setconf.sql script in 11g, but are now part of the Orosecure conf policy in Unified Audit, you'll notice that there are a lot more core audit settings, and these are primarily Database Vault and label security. So there's a few hundred of them. But Oracle are not using Unified Audit by default. They're using the core audit because that's what's enabled by default. So interesting scenario. In terms of the basic default hardening, there's a link here on this slide. I'll put up the slides on my website and I'll pass a link so everybody can download it if you want to have a look at them. This link here just describes the basic hardening that occurs in the database when you install, or so rather where you when you can't even speak. Well, when you enable Database Vault. Primarily, this is things like some parameters have changed that I've just mentioned to the more secure settings. It's things like some of the core rules like DBA, imp full database, execute catalog rule are restricted slightly, very slightly. Things like that have been around for many, many years, like the public execute on UTL-4 file has been revoked, and things like alter, create, drop, and user on user or profile are restricted. So the user, such as sys or system, can't change other people's passwords. You then need to use the user administrator account that is created as part of the installation of Database Vault. There are a couple of gotchas as well. So things like rack with the early versions of 12c. If you enabled Database Vault in a rack scenario, then it hardened the node that you were logged into, but it didn't harden the other nodes. You had to go manually do it by running a script that Oracle documented. And things like if you enabled the hardening or enabled Database Vault in the root container, it hardened the whole server. So if you don't want to have Database Vault in a particular pluggable container, you'd have to manually go and reverse the settings if you didn't want that additional security. Why would you not want it? I would just personally leave it there. The main components of Database Vault, let's start at the simplest level. So there are things called factors. So these are the individual elements of information. So things like IP address, time of day, username, maybe a role that's enabled at the time, the IP address, these types of things. There are quite a number of built-in factors that Oracle have already created, and factors are actually protected with Database Vault as well, so it's recursive. And you can create your own factors. You can create as many factors as you want, and you use these individual pieces of information in rules. Rules just basically return true or false. So if IP address is 192.168.56.89, then return true. If it's not, return false. You can build up a lot of different rules. There are some built-in rules that you can use already, and you can also combine rules into rule sets. And rule sets allow you to have things like and or. So you could say, if all of the rules in this rule set are true, then the whole thing is true. Or if one rule in this rule set is true, then the whole thing is true. So you get this level of configuration that you can enable yourself within the toolkit. The main things that you do with it are the realms, the command rules, and the secure application rules. So a realm is basically like putting a wall around something. So a wall around tables or procedures, any object within the database, essentially, and you use the rules, the rule sets, and the factors to define the rules of the realm. So deciding, how somebody can access a particular table or a procedure. You design it and you say the realm is on this procedure, the realm is on this table, and you decide the rule sets and the factors that are enabled with this. Command rules basically means any SQL command that is available to the database, such as connect, for instance. So you can create a command rule on connect and say, with this command rule, we'll use this rule set or this rule and these factors to say you can only connect to the database from this particular IP address if the tool is not SQL+. And if the tool is HTTPD, for instance. So in other words, you can limit the connection to only Apache web server, but not allow the DBA to connect with SQL+ from the web server machine itself. A secure application role is very similar to the secure application roles that are in Enterprise Edition. So this is a role that is enabled using a function, a PLSQL procedure package, but it's also got the embedded factors, rule sets, and rules tied to it as well. So it's like a secure application rule in Enterprise Edition, but it's got the database vault around it to protect it, to stop somebody changing it. So these are the core sort of elements of database vault, and the three last bullets are the three things you can do with it: the realms, the command rules, and the secure application rules. Privilege analysis is one of the big new things in 12. Well, 12 has been around quite a long time now, so 2013 I think it was. It's fairly complex to play with. There are quite a few gotchas with this, a few issues. I've had a play with it here, and you can see that I've set this up on my sample database. I've got a sample application. I've done some work in the application. So I basically create an analysis. So you define the analysis, you turn the analysis on, you do some work in your database, you turn it off, and then you generate a report. Generating a report populates these views in the table. So the views such as DBA used privs or the DBA unused privs. And you're able to then query these to establish which privileges have been used or haven't been used. But as I say, there are some gotchas with this. The big issue is that at a high level, it incorrectly reports what you've done. But if you start to understand how it works, it's actually not incorrect. Some privileges are not used until they're needed. So things like unlimited table space, for instance. So I can't revoke unlimited table space from my application account that is doing the work because it's going to need it at some point. But the report says I didn't use it. This is a problem. The issue is that you only use unlimited table space when you need to allocate a new block to a table space, to a data file. So when you need another bit of data space, then you use the privilege. So you'd have to do enough work to actually get to the point where you're going to generate the need to use unlimited table space to prove that you did actually use it. The other issue is things like in mine here, it says that I didn't use DBMS Crypto. I actually did use DBMS Crypto. DBMS Crypto is used in a define a rights procedure to encrypt and decrypt credit cards. And I was accessing credit cards as part of this example to create this slide. The problem is DBMS crypto is used in a define a rights procedure. Therefore, it's not reported as used. It's sort of baked into the procedure when it's compiled. Similarly with UTL file, for the same reason. We also need to consider, if we're going to use a tool like this, that it's not just about runtime rights. So we can't just basically turn this on, let all of the users do some work, and then report on the privileges that were used or not, because we've missed two main things. We haven't analyzed the creation of the application, and we haven't analyzed the maintenance time of the application, because some privileges may only be needed when we do an upgrade, and some privileges may only have been needed when we installed the application in the first place. So if we take all these things together, then it's okay as a tool. But the problem is we've got to be aware of all these sorts of gotchas. The other major thing is the duplicate rights. So they're not distinguished at all. So if you've got a grant more than once via a role, via another role, and you use it, it says you've used all of them. It doesn't say which specific one you use, so that you can then say, okay, well, I've used this one. I don't need the privilege via these other two paths, via these other two roles, or this direct grant. So do I keep the privilege that's direct? Do I keep the privilege that's via a role? It doesn't help us with that. So you've got to be aware of that as well. I've got a sample application on my machine. I've got 3 virtual machines. I've not got them all running. I've just got 2 of them running at the moment. So I've got my database server. It's an 11G database, but when I created the examples we're going to see in the slides in a minute, it was a 12C database running Database Vault. But I'm going to use my 11G database for the second part of the talk, which is talking about what we can do if we don't have Database Vault. So I've got the same application there, but I have 2 instances of it, one in 12 and one in 11. So we've got a database server. It's got a schema called Orablog. The Orablog schema supports 2 different applications, so a public-facing website, so a blog, company website, and it's also got a back office application stroke website that supports customer related things, supplier related things, shipping related things, and so on. So internal information that is company specific, that is confidential, should not be accessed by the public. But typical bad design, both applications have been installed in the same schema, in the same database. Both the web servers connect to the database as the same account, which happens to be the schema. You might say that's a silly example, but this is what people do. I see this regularly. See lots of applications that are designed in this bad way. So this is the sort of high-level application hierarchy we've got. This next slide just illustrates the problem. So we've got clients, 2 web servers connecting as the Orablog user, which is actually the schema, and we've got front office data, front office functionality, so PLSQL, and we've got back office data, back office functionality, in other words, PLSQL, all in the same schema, and we connect to the same schema. This is what I see regularly. So this is an issue of data domains. There is no separation of front office or back office data. You would hope that something like Database Vault would help us solve some of these problems, but let's have a look. So I did a number of different hacking sessions. So I wanted to hack the database as an unauthenticated user. So basically going to the public website, hacking through a field on the public website and tunneling SQL injection through to the database. I also wanted to hack the database as a database user who only has create session. So somebody who's authorized, who's got the right to be in the database, but they could actually exploit the database with just create session as well, due to the way the application's been designed. We'll talk about that, what that is in a minute. Also, I wanted to show the problem of a DBA. So a DBA generally has sweeping privileges. The DBA can hack the database. When we talk about hacking, we're talking here not about elevating your privileges to sysdba. We're not talking about bragging rights. We're not talking about somebody who just simply wants to show their immense skill at being a hacker. We're talking about stealing data. So here we are hacking the database as an unauthenticated user with a realm installed in the database. So we're going to do 3 hacks, 3 different scenarios. So we hack the database with no database vault at all. We hack the database with a realm around the credit card table and crypto functions. And we also hack the database with a mandatory realm from 12c around the same data. So we convert the same realm from a normal realm to a mandatory realm. And let's see what happens. So we've got a situation here. We've installed a realm around the credit card table. We can do a SQL injection. It works. So the attacker is successful. He can still steal the data. Database vault, even though it's implemented by default. So it's just deployed. We've even created a realm around the actual data we want to protect. It doesn't work. The reason it doesn't work is because the end user is going through Apache. Apache is connecting to the database as the schema owner. Because it's a normal realm, the schema owner is part of the realm. He's still allowed to see the data, hence the SQL injection still works. So that's interesting. If we hack the same database as a user with just create session, we're essentially doing the same type of SQL injection, but from the command prompt in SQL+, and it still works. We can still steal the data. We can still do SQL injection. We can still reveal the credit card numbers. That's again for the same reason. So we've created the realm around the credit card table, around the crypto function. The problem is we're connected as, on the website part, we connected as the schema owner. In this attack, as a user with just create session, we're executing a procedure called cust, which is definer rights. So when it runs as Orablog. And because Orablog is the owner of the tables and the functionality that's in the realm, we can still attack it because he's part of the realm because he owns the data. It's a normal realm, not a mandatory realm. So again, database vault doesn't work, doesn't stop us from being able to attack the database. If we connect as a DBA and we try and select all the raw details or we try and decrypt them, it works. Database vault has protected the database. So this is the unique case of database vault. So you buy database vault, you implement it out of the box, adds the separation of duties, the basic hardening. It doesn't know anything about your data, doesn't protect your data. If you then add a realm around your data, it still doesn't work in my example. We can still attack it, we can still do SQL injection, SQL injection still works. If we try and attack as a DBA and use the sweeping any privileges, database vault works. So it works in a limited scenario. So you've got to be aware of this. If we add a mandatory realm, so we convert our realm from a normal realm to a mandatory realm, and you can see the code in the middle of the screen where it says realm underscore type is 1, that converts it from a normal realm to a mandatory realm. So it was a 0 before it was, when it was a normal realm, now it's a mandatory realm. There's a big issue with this as well. Because the application connects to the database as the schema owner or a blog, there's a problem. Because we've now basically stopped Orablog from accessing his own data, therefore the website doesn't work. So a mandatory realm is no good. A mandatory realm is not useful for protecting normal business data in this particular scenario. That's because we connected as the schema owner. If we didn't connect as the schema owner, then maybe it would be okay, providing there was no definer rights code. But in this case, it doesn't work. So the slides just show, the slide here just shows the results of the hacking. So we've got three different types of hacking. We've got a web user, we've got a user who just create a session, or we've got a DBA. And the green means database vault didn't work. We can still do the hacking. The red means database vault did work, and we stopped the hacking. And we got 3 different scenarios. We got no database vault in the database at all, therefore all the hacking still works. We've got out of the box database vault. Everything still works. We can still hack it as all of the different 3 types of users. We've got database vault with a realm on the credit card table and the crypto. Only the DBA is blocked. And we've got database vault with a mandatory realm on the credit card and the crypto, and everything is blocked, but the application doesn't work. So that's not really genuine anymore. So the application can't be used. A command rule is interesting. So I mentioned this in the slide on what are the main elements of database vault. So one of the things is you can create a command rule which basically takes any SQL command. So I've just chosen connect as an example, but it could be select, it could be anything that is a valid SQL command. You can create rules, you can create factors, you can create rule sets, and you can add these to the command rule. And in my particular case, what I've done is I've said if we try and connect using SQL Plus from the web server, then we want the command rule to stop that from happening. So this is the classic thing. You want to block a particular tool from working. So, the classic is you want to stop people using SQL Plus from connecting to your database. So you use product user profile. Doesn't work because you just simply rename SQL Plus, you get past it. This is the classic method of trying to block something. A database vault does this as well. So we've created a command rule that basically says if the connection is coming from the IP address of the web server, then also if it's the web server itself, so it's HTTPD, then let it in. If it's not HTTPD, don't let it in. So in other words, even if somebody installs SQL Plus on the web server, somebody can't use it. We can also implement this as I've done. I implemented it on my PC, on the web servers, and in the bottom box with the orange square around it, I showed that I can still just connect using SQL Plus from my PC. So it says hostname Peter's MBP MacBook Pro. So I was able to connect from SQL Plus from Mac, but I wasn't able to connect from OEL 59 or a blog 12, which is the web server. So it works. So we can create a database vault rule that limits how you can connect to the database based on tool or username or time or IP address and so on if we wanted to. Is database vault really duct tape? This is interesting. My view is that it's obviously not intended to be duct tape, but some people might use it as duct tape. So they get the idea that they can buy database vault, implement database vault, install it out of the box, and it should protect the database. The problem is database vault is just an application. You deploy the application to the database, you have to configure it, decide how you're going to use it, add all the settings, etc. You've got to make it do what you want it to do. If you've got a database that hasn't been protected already, so you haven't done basic hardening, you haven't got separation of duties, you don't have data access controls, you haven't got least rights on your users, and so on, then database vault isn't really going to help you very much. You really need to do the basics first to get your security of your data right first, and then database vault is a great tool. But even then, you should actually think about how you're going to deploy it, what you're going to do with it, what do you want to achieve with it, and implement it carefully. So buying database vault is okay, but just using it out of the box is not going to really add a massive amount of value. You've got to think about it that it's a product and you have to configure it and use it. So is it duct tape? It's only duct tape if somebody thinks that they can just buy it and deploy it and it will do something. If you actually use it correctly and you've got core hardening and everything else done first, then obviously it's not duct tape. What happens if you don't have database vault? So you can't afford it, you're on SE, SE1, SE2. What could you do? You could try and replicate the technical features of database vault. So try and re-implement it yourself. Hard to do, obviously. Or you can remove as much of the problem that is solved by database vault. So in other words, do your basic security. So get the least privilege for all of your users. Lock down your database, do the basic hardening. Add proper data access controls. Make sure the access to all of the data is actually designed and correctly implemented. Add context-based security. So you can do context-based security without database vault. I'm going to give you some examples in a minute and show you how that's possible. Obviously, don't use things like defaults. So, don't use the default rules. Don't use the DBA rule. Don't use imp full database. Don't use select catalog rule. All these things increase the security risk because they give you far too many privileges that you don't actually need. And obviously consider the application design. So mine is obviously very badly designed in that my web servers connect as Orablog. Orablog is the schema owner, and all of the code and the tables are all in the same schema. So there is no security. So you can't make a grant between a procedure and a table because they're in the same schema. If you'd put the tables in one schema and the code in a different schema, then you would be able to create grants between the two. You would have proper data access controls. You start to have least privilege and so on. So you've got to consider the basic architecture and security design of your application as well. So what do we need to replicate database vault? obviously database vault is a very big product. You know, there's declarative APIs, there's factors to think about, there's realms, there's rules, there's secure application rules, command rules, you know, there's mandatory realms, there's separation of duties, there's hardening, there's parameters, there's many, many elements. There are three sorts of things we'd need to consider if we wanted to replicate database vault. We'd need to be able to capture setting a role, and there's three ways to do this. Was probably more than three ways, but there's sort of two core ways. So the set role and there's dbms session.set role. If we wanted to create a secure application role, we need to be able to detect when somebody tries to set a role to execute some rules to say, hey, should you be able to set that role? So similar to Enterprise Edition, secure application role, you define a role as a function, a PL/SQL package assigned to it. The only way we could implement that outside of this would be to be able to trap, in the sense of an interrupt, trap the setting of a role. If you wanted to detect changing of a parameter, for instance, you'd need to be able to detect alter system. If we wanted to implement the sort of core functionality of a realm, we need to be able to detect the use of any privilege with any in it. So select any table, for instance. There's no supported way to trap set role. There's no supported way to trap alter system or select any table. There is a supported way to trap insert any table or delete any table, which is a DML trigger, but not select. There is no such thing as a select trigger. This is the problem. The other issue is things like alter system is DDL, but it's not trapped by a DDL trigger, so we couldn't use a DDL trigger. Some actions can be trapped by triggers, system triggers, such as create, alter, drop, and most of them are DDL, but there are some big gaps, so some things are missing. So to re-implement database vault and achieve a similar level to the existing database vault would obviously be an enormous task anyway, in terms of coding, but there are some gaps that we can't bridge easily, so we can't actually do it. What we need is a select trigger. So there's no select trigger in an Oracle database. We could use something like an FGA handler function, but you'd need Enterprise Edition, so this wouldn't work for Standard Edition or XE.
Well,
We could
sorry to interrupt.
yeah.
What's FGA handler? I mean, this is something I've been thinking about a lot. How do you do a selection? I'm so excited. So what's FGA?
A fine-grained auditing. So this is a feature of Enterprise Edition. So it allows you to have auditing based on rules that you define. So instead of just auditing select on the table, you can say audit select on the table when it's Fred or when it's Bill and when it's 3 o'clock and when it comes from this IP address.
And then you detect the audit event?
Yeah, it generates an audit record into the FGA log dollar table. But as part of this policy that you create for each rule that you want to set up, you have the ability to create a thing called a handler function. So you can create a PL/SQL function that fires every time this rule fires. So potentially you could use FGA as a select trigger.
Got it.
So you could basically have it firing for every select on a table, and then you could use the handler function to implement the rule or whatever you want to do. So in one sense it would be possible, but it wouldn't work for SE.
Okay.
And again, materialized view, there are limited things we could do to
how?
Sorry?
Like, what would you do with a materialized view to detect the select?
You could use it to basically detect some selects, but not all selects. Because of the way that the materialized view works, it's possible to effectively create a trigger on it in some circumstances. So therefore, you could have the trigger fire where there's essentially a select, but it's not really a select as far as the materialized view is concerned. Hence, a trigger would work. It's a bit more complicated to discuss in 2 seconds here, but I can discuss it offline with you later if you want.
Okay.
The one I want to focus on is a trigger on odd dollar. So if we could create a trigger on odd dollar, then we could essentially create a select trigger. Because what we could do is have auditing enabled on, say, set role or alter system, have a trigger on odd dollar, so that when the audit record is generated, essentially fires a trigger, and in the trigger we implement the rules. This is not possible. So we can't put a trigger on any table owned by sys or an odd dollar or user dollar or whatever. We can't put an FGA policy on it. We can't add a normal trigger to it. We can't, we can't basically do anything to it. It's very limited in what we can do. We can move odd dollar to a different user. So we can move odd dollar to the system user, and we can then add a trigger to it. But we're not adding a select trigger. We'd add an insert trigger. So we basically then have auditing that detects the insert of the record into odd dollar, and then we have to decide whether that insert is actually the thing we want to detect, so select, and then we can essentially simulate a select trigger. Up to 11.2, when Database Vault is installed, odd dollar is actually moved to the system user, but Oracle don't support you doing this. So I've just played around with this just as an example. So what I've done is created a trigger on odd dollar. So I've moved odd dollar to the system user. I've created auditing on select on my credit card table. I've then got an insert trigger, and within that insert trigger, I'm basically saying, is the table credit card? Is the action 3 select? Therefore, I can do something. So in other words, what we're doing here is creating a simulation of a realm in Database Vault by blocking any select on the credit card table. You would have to implement all of this yourself. You'd have to obviously have the problem that you've created a trigger on odd dollar, you've moved odd dollar, there will be a performance impact. This is not practical. It's just really to illustrate what might be possible. We can also create a secure application rule. So what I've done is created my rule, which is the function at the bottom, system.stk rdef sar. This is my rule that detects whether the IP address is .2 or not, returns a 1 or a not. I have then basically a trigger body again. The trigger body is basically saying, is the actual audit rule 55? If it is, then we run an anonymous block. In the anonymous block, we go and look up and see if there are any rules or factors that have been created for this particular object. We then dynamically execute it. We get back our 1 or a 0, and then we use that to then decide whether to block the action or not. So we can create, in essence, we can create a secure application rule using a trigger on odd dollar. So we can simulate it. But this is not practical. This is not something we should try and do. Oracle would not support us with multi-tenant architecture in 12c. This is not going to work anyway. This will work in a lower database, a legacy database, but it won't work in multi-tenant. So this isn't something we should really be doing. But it's just interesting, to show in a slide that it is possible to simulate some of this. What are we trying to do? Well, we're not trying to replicate the actual functionality of Database Vault. What we're trying to do is replicate the intent of Database Vault. And a lot of Database Vault is trying to solve the bad design problems that people have. So people log in as sysdba all day, every day. They use sys and system. They use the DBA role. They have sweeping privileges. They don't have any separation of duties. They put all of the code and data together. So there are no grants. There's no security model. We don't need Database Vault to solve these problems. We need good security design. That's the issue. The other element is context-based security. The other one is the privilege analysis, which we'll come back to at the very end. Context-based security, I'll give some examples of. So we need good basic security design to start with. Even without Database Vault, we should have good database security design. Even if we buy Database Vault, we still need good database security design. So we need to basically make sure that the database is locked down. We have separate data domains. We separate the functionality from the data. We even have critical functionality or data separated from none. We have least rights, data access controls, hardening, patching. All of this is a lot of work, but we need to do these basic things first anyway, even if we implement Database Vault. We need to harden lock down the database. So if we do, I'm not going to do the demo now because I'm just we're already at nearly 4:45 UK time. We could hack the database again as the 3 different types of hacks that we did that I showed as part of the deployment of Database Vault to show that basically you can hack the database. If I'd lock down my database and I'd redesign my data access controls, I'd change my database so I'm not connecting as the schema runner anymore, I fixed some of the SQL injection problems, none of those hacks that I showed would work. And we didn't need Database Vault to solve that. What we need is good security design. And if we basically then don't allow a DBA to log in as sysdba, and we have a DBA rule that is designed for day-to-day use that is not excessive, so he could still have some any privileges, but we could have things like DDL triggers protecting the use of some of the any privileges to stop a DBA from exploiting or doing things you shouldn't do. We could get away with not granting select any table by basically saying, if somebody needs access to a particular schema, give them access to the schema. Don't give them access to everything in the database. So we can lock down the database and it would solve the problem. One of the biggest problems is the system any. We have this perceived need for system any privileges, like select any table. Often this is for development or deployment of code or DBA-like activities. There's a number of ways we can solve this. If you create code, you can say, create table scott.table or create procedure scott.procedure. You could log in as Scott and you could just say create table or create procedure. You could log in with somebody who has create any procedure and create any table, and they would need create table scott.table scott.procedure. So there's a number of scenarios going on. The best solution to avoid the need of system any privileges is to log on as the schema. But that's a security problem in itself. So a better solution is to use proxy. So you can allow somebody to proxy to the schema, allow them to do issue statements like create table, create procedure, create sequence or whatever. They all work because as far as the database is concerned, you're logged on as the schema, but actually you're logged on as yourself and you proxied to the schema. This means you can audit anything that person does without having to audit everybody else who's using the code at the time that's being deployed. So it's a good solution to use proxy. There are a number of types of system any privileges. There are the ones that create or change things, like create any procedure, and there are ones that access data. So select any table, insert any table, these types. For release, a release person should probably not be reading data. Possibly needs to change data, possibly needs to insert data, but in general, they're going to be using structural change privileges. Create a procedure, create a table, whatever. We can get around this with proxy, so we don't need these privileges. In general, interactive users shouldn't need system any. So somebody who logs in directly should be given privileges on the objects they need. Schemas shouldn't have system any. They should be limited to their own schema. Any access to another schema should be direct grants. DBAs can work around not needing system any privileges. And core accounts such as sys or system or DBA, you shouldn't be using them. You should have your own accounts that are designed correctly for day-to-day use. We can also do context-based security. So there's a number of levels to this. So this is talking about partially sort of emulating database vault in one sense. So the classic way of doing database vault or VPD was to use views. So basically you create a view that adds rules around what you're going to do to access with the data. So limit the data, filter the data. But you could also add a function into the view that says who can access the view. So you can simulate database vault or VPD essentially. So let me just run a demo that shows this one. So I've got a quick demo here. I'm logging on the sysdba. I'm just going to create a sample user who's going to own the data. So I'm creating a user called VU, giving him a password, giving him some privileges. He's now going to connect and, sorry, just find the right place. We're going to connect as VU and, sorry, I'll start again. We've created VU who's going to own the data, and I'm creating a user VA who's going to access the data. I'm now going to connect as VU and create the data. So I'm creating a table. I'm inserting a couple of rows into the table, committing those. I'm creating a function that is going to be accessed via the view. I'm actually creating it as a package. So I've got this function, it's fairly simple. It's just basically saying if the session user is the user that I want it to be, so in other words, VA, access the data. If it's not VA, you're not allowed to access the data. We can then create a view and we can use that function in the view and also select the two rows from the table. This isn't the ideal way to do it. This is just a demo. The ideal way to do it would be to use the function in the where clause. Therefore, the function fires for every select against the view. But it doesn't really matter. It's just a demonstration to show you the idea behind it. So we can then grant select on the view to VA. The user is allowed to access the data. we're just locking the account. So we're locking the schema, so no one should be able to connect as the schema anymore. And then we're going to connect as VA, and we can access the data. So we did select star from the view. We can access the data. It works. If we create another user, VB, so VB is another user, and interestingly, he's been granted select on the view. If we connect to VB and we try and select star from the view, he's got a permission to select from it. He can't see it. So we've essentially replicated a realm in database vault parlance. So what we can do is we've got grants on a table. We've actually replicated an element of a mandatory realm. So we've stopped a user who's got a grant on some data from reading that data. So we can simulate database vault to some level. We can also do context-based security in terms of the access to the data itself. So if we look at context DML, this basically runs through almost exactly the same demo again, but this time it's doing it within the context of DML. So we're creating the user VU again, so dropping him and recreating him. We're also creating the access user VA. We're connecting as VU and recreating the same data. So I've just created the same table, 2 rows of data. I'm also making a couple of grants, delete and select. I'm having to grant select and delete because I've got SQL 92 security set to true in my database. Therefore, I can't grant a selective delete. I can't do a selective delete unless I've actually got a read privilege. That's why I need to have the 2 privileges. I'm now going to create a trigger. So the trigger does essentially the same thing as the view, except it's now embedded into a trigger, and I'm only doing it on delete. I could do it on insert and update as well. And it's the same code, basically VA. So we connect as VA, we delete a record, it works. We're allowed to do it because this trigger says we're allowed to do it as VA. So there's 2 levels of security. There's the grant on the table itself, and there is the context-based security embedded into the trigger. We can now connect to sysdba and create another user VB. VB has also got delete on the table, and obviously it has to have select because of the SQL 92, but delete is what we're interested in. And if we connect as VB and try and delete some data, even though he's got privilege, he can't delete it. He's blocked by the trigger. This is essentially what we want to achieve with context-based security, but we don't need database vault to do this. There's a lot more work, obviously. So instead of it being a declarative framework, we've got to write the code separately for everything we want to do. If we connect as VU, and VU tries to delete the data in his own table, so he's the object owner, he also can't because he's not VA. This is essentially a mandatory realm for insert, update, delete. Much harder to do for select, unfortunately. We could do it through a view, but you'd have to ensure that nobody could access the base data. We can also do the same thing for code. So we can add context-based security to code. Again, the same problem. It's not like database vault where we can just create a realm or a command rule. We could do this in cloud control with point and click. We can still have to write a bit of code, or we could do it from the command line with APIs. It's harder to do because we have to implement everything ourselves. So we're just going to connect as sysdba. We're creating a user CC key who's going to own the key access function. Who's going to use the key access function. We're going to connect as Orablog, who owns the code. So Orablog owns this function key code that is allowed to access the encryption key, which is stored on the file system. And it's using this security checks here. So basically it's using who called me. There is a new function in 12c that makes this slightly easier to use, but we're using the old version. We can check if the owner of the code that we're being called from is CC key, if the function we're being called from is STK key API, and we're being called from line 5 and it's a package body. And if it's not, then raise an error. We can then grant execute on this to CC key. We can then create the access function. So we're creating this as a package again. So STK key API, which is what we said it should be. It's line 5, which is what we said it should be. It's a package body, which is what we said it should be, and so on. We can now go and try and use this. So we call it correctly through the API. It works. If we try and call it directly, it errors. So context-based security, we can add this into code if we want to. Again, hard to do because you have to write it yourself. We also need to implement separation of duties. This is harder to do because people generally don't do it. A database vault gives you an account manager, so somebody who manages user accounts, because system can no longer change passwords or create accounts. It gives you an audit trail admin account. It gives you the vault owner. It gives you the ops DBA and the vault owner. We would probably want to add more than what Database Vault gives us. So we want the account manager still, somebody who can manage user accounts. We want the audit trail manager. We want the security DBA or admin, and maybe even an audit viewer. So we need to create these sort of job descriptions that are security related and decide what these are, and then assign these to real people, and then create roles and access in the database that matches these job roles, and then grant these roles to actual real people. We can create separation of duties ourselves without Database Vault. We can also use additional technical solutions. So we could use things like a DDL trigger to limit the use of alter user, which is essentially what Database Vault is doing. So in Database Vault, sys can't change people's passwords anymore. And we can implement the same thing. We can create an alter user trigger. We can create an alter trigger that fires on the user object, and we can basically make sure that sys can't change somebody else's password, a schema password or sys password itself or system or whatever. We can do the same things without needing Database Vault. If we want to block something like a parameter change, this is harder to do. So limiting alter system basically means we'd have to block the use of alter system. But alter system is used for lots of things, not just changing a single parameter. In 12.2, there is now the lockdown profiles that actually makes this easier. So in 12.2, we're actually able to limit the change of a particular parameter using a lockdown profile. So this is much easier to do. In 11 or 12.101 and 102, it's harder to do. But we could do it by basically limiting the use of alter system. We could audit the use of alter system. We could have a trigger on database startup and shutdown to basically go and check all the parameter values, and if something's changed, create an issue and solve it. We could also protect things like the SB file on Linux with the chatter command. So we can add the immutable attribute to the actual SP file and prevent it from being changed. We can also implement a command rule for free without Database Vault. So I've got one here, so I can go to my web server. That's the wrong one, sorry. Go to my web server, and if I try and connect with SQL Plus from the web server to the database, which is essentially what I was talking about before with the command rule. Oh, that was a bad demo. It failed. But anyway, you can see the one I tried a few minutes earlier before I started the talk. I tried to connect to Zoroblog. There is a trigger within the database. I must have locked the Zoroblog account as part of one of the demos by accident. We can see that if I try and connect to Zoroblog from the web server, then it's blocked by the logon trigger that I've created. So a logon trigger can actually simulate the same thing as a command rule in this particular example. Obviously, it's harder to do for different command rules. So we can do a lot. Privilege analysis is probably the easiest to simulate because we can just use auditing. So we can audit everything that somebody could possibly do within the database. We could do some work. That could be the creation, it could be the maintenance, it could be the general runtime. We can match that with the privileges that people have. You can use the free scripts that are on my website, like find all privs. We can match the two together. We can understand then if somebody used a privilege or didn't use a privilege. We can actually simulate privilege analysis fairly easily within a standard edition database or a database that doesn't have Database Vault, just simply by using audit. So in conclusion, good security design is needed first, even if you're going to buy Database Vault. You should do basic lockdown anyway. You should start to think about not using system any privileges, so the ones with any in the name. You should stop using sys and system and DBA. You should design your own users. You should think about using proxy for deployment of code and so on. Is Database Vault duct tape? Not if it's used correctly. If you simply buy it and think it's just going to lock down your database, then essentially in that sense it is. But that's a choice, not by design. So treat Database Vault as an expensive product that should be used correctly. You need the basics right first, good security design, then you can think about Database Vault. But if you haven't got Database Vault, then as I've just shown, we can still do all of these basic things and achieve a lot of Database Vault by simple security design in the database without buying it, basically. So if we have any questions now, I'm happy to take a few questions before.
Yeah, let's see. If anyone has a question, feel free to type it in. So Joel has a question. What's the footprint of Database Vault feature in the overall performance of the database instance?
Depends what you're doing with it. This is the classic issue with anything in a database. The classic argument is audit. Is audit a performance problem in a database? Well, yes, if you do silly things with it. No, if you design it carefully. So if you audited actions that should not occur, there shouldn't really be a performance impact. But if you audit access to a particular table that's hit 200 times a second, there's going to be an issue. And it's the same thing with Database Vault. If you decide to create a realm around something that's accessed 200 times a second, you're going to have to test it and actually check whether there is an impact, because when the realm code fires, that code is firing in the background for every select against that particular table. It's going and executing the rules and the factors and the rule sets and everything to decide whether to block access or not. So you'd have to test it, unfortunately. There's no black and white answer.
Yeah, so and unfortunately, these hard hit tables are the ones that you want to protect the most usually.
Yes, exactly. This is a problem.
So Joel's second question is standalone versus rack specificities when it comes to Database Vault.
Yeah, I mean, the Database Vault is implemented within the database kernel. So, it's executing every time you issue a query to the particular thing that has got a realm or a command rule or whatever on it. So it's running in the context of the rack database, not a particular rack instance. So there are some issues, particularly I mentioned at the beginning, like the hardening. So if you install it from one particular node, it hardens that node and doesn't harden the others. So in essence, it should work across rack seamlessly, but there are a small number of gotchas, basically.
John Larkin has a question.
Yeah.
Will Data Guard still work log shipping in parentheses if lockdown sys and system?
Database Vault is supported with Data Guard. I don't know the specific answer, but in general, it's supported. So yes, it should work. I don't know how you get around it, but it should work because it's supported.
Okay. Ravin's question. Is there a dependency between Data Vault and Audit Vault?
No. Well, I say no. There is no dependency that if you buy Database Vault, you've got to buy Audit Vault. But there is a dependency the other way around, because Audit Vault does use Database Vault under the skin. But you don't buy an additional license for it. It's part of the Audit Vault license. So one way, yes. The other way, no. But you don't need to care about it because it's part of the Audit Vault license. So I would say no in general.
So if you what are the key points? We can implement database. We implement what are the key points for system.
So I didn't get that.
We talked about that. So maybe. Well, somebody joined us a little bit late.
Okay.
There are some questions, but maybe this. Sorry, guys, I have to skip a few. Cant asks, can Database Vault, I guess, be in the same? Let me read it as it's written. Can Database Vault same in CDB also? What do you make of it?
You mean, can you use it in the container database? Yes, you can.
So, yes.
Yes.
So
So
there are a lot of
if you got multi-tenant architecture, then you must install Database Vault in the root container first before you can use it in a pluggable container.
you
You
mentioned
can't,
that.
yeah, you can't only install it in the pluggable container. You've got to put it in the root container as well.
Okay, I guess we gotta stop here.
Yeah,
But
that's fine.
Pete, thank you
Yeah,
very much.
that's all
I
right.
really appreciate this. There was a lot of enlightening moments in the presentation.
Okay, great.
We've got a lot of feedback about, oh, Pete should do another webinar about good database security design,
Yeah,
like
yeah.
at least 10 or 15 mentions. So we should maybe talk about that.
Okay. Yeah, that's fine. Yeah, I can do another one. That's not a
Okay,
problem. We
thank
can
you.
try and beat Martin Widlake's sign up next time.
We'll beat him. We'll beat him.
Yeah.
Uh, and the other question was that, will the recording be available? Yes, in a few days it will be
Yeah.
available, and we'll email everyone. So
Yeah.
again, thank you very much, Pete. I really appreciate your time.
Okay.
We all appreciate it, and thanks
That's all right.
everyone for joining. And we'll be next month. We'll have a talk about database backups in the cloud. It's already available online if you want to register, and you'll receive an invitation email in the following days. So see you all in the next webinar in February. Thank you very much.
Thank
Thanks,
you.
Pete,
Bye.
again. Bye bye.
Thank you. Bye.